So today in class we talked about functions, and now I want to talk about equations as function rules. So we're going to look at some different examples using that f of x that we talked about. So in our notes earlier in class today, we said f of x is the same as y. And if you can keep that in mind, then you're going to be very successful today. So I want to show you some different versions of f of x and how we can apply it. And we're just really using our same equation rules that we started with at the beginning of the year. So for example 1, if I gave you the function f of x equals 3x plus 4 times the quantity of x plus 1, we can do a couple of different things here. So what if I said, what is f of negative 2? Okay, well I want you to notice that this negative 2 is in the same place as the x. So what this is translating to is saying that x equals negative 2, and you're going to plug it in to the equation where we see x. So we would write 3 times negative 2 plus 4 parentheses, negative 2 plus 1. And at this point, you could use your calculator. You can use your smarts to solve this. Remember, a negative times a positive is a negative. So we would have negative 6 plus 4, parentheses first, according to operations. Negative 2 plus 1 is a negative 1. Now I have negative 6. Positive 4 times a negative 1 is a negative 4. So I get f of negative 2 equals negative 10. Now what that means is in this equation, if we were to graph it, and we'll get there eventually, if we were to graph this in a coordinate plane, then the coordinate negative 2, negative 10 would be on the line. In like manner, we can go the other way. If I said, what is the value if f of x equals 39? Okay, well notice now that x is still an x, but we said f of x as a whole is y. So really, I'm saying y equals 39. So again, we're going to plug this in. We're going to say, instead of f of x, I'm going to say 39 equals 3x plus 4 times the quantity of x plus 1. And now I can use my rule to solve the equation for x of 3x. Now I'm going to have to distribute here. Remember to distribute on both numbers. I can collect like terms. 7x plus 4. I can undo my add subtract. And then I can undo my multiply divide. And I get x equals 5. So what does this mean? This means that, again, if we are to graph the same equation on a coordinate grid, I would have the point 5, 39 on my line. What I would like you to try, and you can answer this on the form, is I would like you to try a second example that's very much like this first one. So if I gave you the function f of x equals negative 2x minus 4, parentheses, x minus 1, could you tell me what is the value of f of 3? And what is the value if f of x equals negative 17? So what I would like you to do is plug in like we've done before, get your answer, and make sure you answer that on the form, and then we can talk about it in class. Another way that we can look at this is if I give you a coordinate point. So in example 3 here, I'm going to give you the equation. Now I'm not giving you f of x this time. I'm going to give you y equals 5x plus 4x minus 6. But instead of giving you an f of x equals something, what if I said I have a coordinate point of 10 blank? Or if I had another coordinate point of blank 12. Remember we talked about coordinate points, so this is my x and this is my y. So you're simply going to plug in. If x is 10, then whenever I see x, I'm going to put a 10. So 5 times 10 plus 4 times 10 minus 6. 5 times 10 is 50. 4 times 10 is 40. And it's simply using my order of operations. 90 minus 6, I get 84. So what that means is, when I graph this equation, I will have the coordinate 10, 84 on my line. In like manner, if I have y, so now I'm going to put the 12 where the y is, and I'm going to solve for x. Again, all we're using here is order of operations and our equation rules, so I can collect like terms. 9x minus 6, undo the add subtract, undo the multiply divide, and x is 2. So again, if I graph this, I would have the coordinate 2, 12 on my line. So what I would like you to do is I would like to give you the equation y equals negative 3 times the quantity of x minus 8. And now I'm going to give you a table. Now, tables are just like coordinate points. Same information in a different format. So if I gave you the table x, y like this, and I gave you that x is 1, could you find y? If I gave you x, if y is 27, could you find x? And that is also going to be on the form. So you'll have example 2 and example 4 on the form. Again, we're just plugging in. This really is just a matter of looking at it in a different way. My last example for you uses some of those new vocabulary words we talked about. So if I gave you the function f of x equals 1/2 x plus 2x minus 1/2, and I said, what is the range for a given domain? Now, this is some new vocabulary. I want you to remember, based on our notes we took in class, domain is another way to say x, and range is another way to say y. So this is not as tricky as it appears. So what is the y value if I give you an x value? That's what this is saying. So if I gave you domain equals the set of -1, 0, and 1, I want to know what are the range values that go with it. So I'm giving you essentially 3 different x values. So you need to solve this 3 times. So for the first one, I can say, I can even put the -1 in place of x, so I know I'm doing that one, equals 1/2 times -1 plus 2 times -1 minus 1/2. And again, you can use your calculator, you can use your brain. So we get -1/2 minus 2 minus 1/2. Well, those are all negatives, so this is going to be a -3. So we can say f of -1 equals -3. So my first range value is -3 because my coordinate, my x coordinate would be -1, my y coordinate would be -3, like we saw in our table up here as well. If I wanted to do f of 0, again, I'm simply plugging in 0 in place of x. 2 times 0 minus 1/2. Well, this is 0, this is 0, minus 1/2. So f of 0 is a -1/2. And finally, I can do f of 1. And again, I'm just plugging it in, 1/2 times 1 plus 2 times 1 minus 1/2. So 1/2 plus 2 minus 1/2. Well, I know 1/2 minus 1/2 is 0. So f of 1 equals 2. Now what this is saying is, again, these are just our coordinate points. If we graph this equation on a coordinate plane, we would have on the line -1, -3, 0, -2, and 1, 2. So in class, you're going to practice this, where I give you, it's going to look a lot like this first example where I give you f of something, or I tell you f of x equals, and you need to solve that. Make sure that you've answered example 2 and example 4 on the form, and I will see you later. Have a great night.